So in the previous class, we were talking about the MAC addresses and how those MAC addresses are represented and why these MAC addresses used. Means if the network devices suppose wants to exchange the information within the same network, so they can use the MAC address for exchanging the information. And we will try to discuss the another address is IPv4, the Internet Protocol version v4. So this is the network layer protocol. So in network layer, they're having the IP version 4 and IP version 6, Internet Protocol version 4 and Internet Protocol version 6. So it says that version 4 means it used 32 bits and version 6 means it used the 128 bits for that. So if you write 2 to the power of 4, it will give you 32 bits. If you write 2 to the power of 6, it will give you 128 bit in size. So the network layer protocols, we say one is IPv4, IPv6, and other two protocols which are used by the network layer is one is your OSP, Open Shortest Path First, to establish a route from source to destination in the network, and for checking the connectivity, whether the source device and the destination device, whether they are connected or not. To check that, another message is there. We call that Internet Control Protocol message or Internet Control Message Protocol, ICMP. So what are the basic operations of this network layer means? It first, to identify any device in the network, the device should have a unique name. So that unique name is identified with the unique address in the network. So that address is provided by your network layer that we call the IP addresses. So first operation of your network layer protocol is addressing the end devices to configure with the unique IP addresses. And another one is once it receives a segment from its upper layer on sender side, that is from your transport layer, those segments are goes through the network layer operation to generate the packets. And once the encapsulation done, then those packets will go through the path which is established by your network layer to reach the destination. And on destination side, the reverse process of encapsulation takes place, that is the de-encapsulation, so that the packet header will be deleted. So this is the major operation of your network layer. One is addressing devices, encapsulating the packets, then routing the packets, then decapsulating the packets on destination side. So here, let us see this by just observing, how the sender side, this is a sender, and this side is your receiver. So if you follow the OSI model, we find the 7 layers. The 7 layer, generally the users try to generate the protocol data unit at the application layer, and we say that this application layer, your presentation layer, and your session layer, and your transport layer, there we call them as your process to process communication. And there is a virtual connection actually, but there is no the peer-to-peer connection. But whereas the lower 3 layers, they are connected with the peer-to-peer connections, layer 1 and layer 2. So in this case, how this data is encapsulated. So on sender side, let's take this off. Okay. On sender side, the data will be generated by your source. So in that, it will having the addressing, the IP address of your source and your destination. It will go through the lower layers on sender side, and when it reaches to your network layer generates the segment into the packets, and those packets further forwarded to the next layer, that is your data link layer. They generate the frames. From frame, it generates the bit stream, and that bit stream goes through the internet protocol or internet devices, and and then it reach to your destination site, and destination the decapsulation will be takes place. So these are the basic operations of your network layer, right? Which we are talking about this. So in this, in encapsulation, what happens at the encapsulation side? So upon receiving on the sender side, upon receiving the transport layer, segment we call. So the actual data which is headed by the transport layer header, we call that your segment header. So in this segment header, it will mention whether it is using the TCP connection or your UDP connection. Okay, and what are the different port numbers are used that will be there in the segment of your transport layer. But whereas in network layer, the IP header will be there. So this IP header will be added to this entire segment, so that becomes your IP packet. So in that IP packet, the IP header gives the source IP address and destination IP address. Source IP address means, as we said, the network first operation is addressing the end devices. So every device is identified with the network addresses. That is 192.168.some10.10. And if the destination is also in the same network, then it will also have the addressing like 192.168. Suppose 10.28 like that. So this source IP address and destination IP address will be there in the IP header, that is the main. So here, the basic characteristics of your IP addressing is, it is a connectionless. That means whatever the segments received by your network layer, it will simply add its source IP address and destination IP address and inject that particular packet into the network. So there is no prior communication between source and destination. There is no control message exchange. Okay, so that's why it is a connectionless. So there is no connection that will establish before sending these packets actually. So as you know, that when the packets are traveling through the unreliable network, there is a possibility of some of the packets be lost. So that is the best effort. And another one is, these IP addresses are the media independent. So they are not depending upon whether the packets are traveling from your source to destination through your coaxial cable or copper wire or fiber optics or any other media, the wireless media. It is independent of the media part. So as we said, in connectionless, simply whenever the packet is ready by the sender, so that packet can simply inject into the network, and it will go on the way, based on the IP source and destination IP addresses, either this way or that way, and it will reach to your destination. So in this connectionless network, what we can see, as there is no prior exchange of information that I want to send this packet, whether you will receive or not. But upon receiving that particular packet, destination device decapsulate the IP header and check whether the destination IP address is matching with that device or not. If it is matching, then it assumes that the packet is legally belongs to that device. So then it starts doing the decapsulation. If it is not matching, then simply it can forward to the next device, next hub which is connected to it. And in the best effort, as says that if sender sends suppose 3 packets, 1, 2, and 3, but on receiver side, during this transmission of these packets via this internet, so while going, because of the software problems or because of the hardware problems of these network devices, if their processing speed is suppose low, some of the packets may be dropped. If these devices are attacked by any of the attackers, suppose, then the attackers make these devices busy with some other task, so that this device cannot accommodate these packets, so they will simply drop here. So that may not reach to the destination site. So instead of the entire data is divided into 3 packets, and those 3 packets transferred, but out of those 3 packets, if only 1 and 2 packet is received, if third packet is not received, that means it can say that the IP addresses are just going through the path which is established between source and destination, but the IP address doesn't guarantee that all these three packets will be received by the destination. And the third characteristic, as said, the media independent. In this media independent, the packets may go from your source to your destination through a cable which is connected your source and your first network edge router we called, using your copper ethernet, and the network device to network device connection may use the copper serial cable or may use the optical fiber cable. But whatever the media is used to connect these network devices and the end devices, it doesn't matter for the IP protocol or network layer protocol to format that message. Simply, it just gives only the source and destination IP addresses itself. So, what will be there inside the IP packet header? So, this IP, as said, the IP packet header will just have only the source IP address and the destination IP address. So, upon the any packet which is received by any of your destination or any of the devices during their transmission, suppose this is source and the destination. Upon this packet received by any of the router, suppose R1, this router R1 will simply check the IP header of your source IP address and destination IP address. If the destination IP address match with this device, then this router can decapsulate that particular packet. If it is not matching, simply it forward to the next hop in the network. So the next device in the network will also go through the IP header. In that IP header, go through the destination. If it is matching, then it can use that packet, it can open. If not matching, it forward to the next. And this process that continues in the the network forwarding the packets from source to destination. So as IPv4 packet header consists of fields that contains the important information about that packet. So what are the different and these field information is examined by the layer 3 process. Layer 3 process. That means these information used by your end devices as well as your network devices. In network devices, it is used by especially the routers. So in network devices, you will have the hubs, you will have the what you call switch are there, but switch and hub, they don't use this field. They use the MAC address field. Right? So the IP packet header field consists of your 32-bit, as we said, the IPv4, that is 32-bit in size. Okay, so it divides into 4 bytes. So it consists of the IPv4 header field consists of the version, which version it is using, that is IPv4 version or your IPv6 version. Then it will use the differential service or the differ service part of your the protocol data unit, and from this protocol data unit it will use the header checker to check whether the packets are legitimate packets or not, to check the header, and it will use the time to live. That means what is the distance between your source and destination. So the source and destination distance is evaluated using your routing protocols, maybe static routing and dynamic routing protocols. So in routing protocols, it gives how many number of hubs are exist in between source and destination. That means how many network device nodes are there. If this time to live is not there, then your packet will be infinitely, it will what you call travel around the network, and it will give the congestion. So suppose if time to live is given that suppose 10 hops, suppose after 10 hop travel of the packet, that will be discarded from the network. And it use the protocol version. What are the different protocols are used in that. So as we saw that the protocol, whether you are using the open shortest path or you are using the ICMP, Internet Control Message Protocol, and it use the source IP address and destination IP addresses. So every device will the any intermediate device, they will first check their IP address with the destination IP address if they are matching or not. So in this, how the IP addressing will be takes place. So let us see the basics of your IP addressing. As we said in IP addressing basics, if you take the IPv4 version, it takes 32 bits, and this IP address is partitioned into two parts. The first part of this IP address is your network portion and the host portion. The network portion is used to identify which network it is, whether the same network or different network that will be used. And in that network, to identify the host portion will be used. Okay, so this, if the meaning of this one is the the end devices which are in the same network will use the same network portion. So in the same network, let us assume, in our class, if it is a network, we call the private network, suppose. So the class, the SP1 250 is the network address, and the host address is our individual names. Is the host address to identify. So SPDO, the SP1, your 250 is your network portion type. So to identify within that network, that means every device in the same network will have the same network portion. If network portion is different, means those devices are in different networks. So when they are in the same network, then the host portion should be unique for every individual. There should not be any conflict. If host network portion is different, then the host portion may have the same number on different networks. So in this, if you recall, to do the static IP configuration for your device, if it is connected to your network, it will have two parts. One is your IPv4, that addressing part, as well as the subnet mask. So this subnet IPv4 is unique IP address for any host. So that will have, for every host there will be a unique, and you will have the subnet mask in that. So why this subnet mask is used means to identify or to determine the network part as well as the host part. The main operation of your subnet mask is to identify the network, whether the same network or different network it is. But the default gateway, we call the default gateway, or we call the edge routers. Okay? So this building is connected to all the devices in this building. They are connected to one router to connect with the public network or internet. We call that device as your default gateway or edge router, we say. So this default gateway address is required to reach the remote networks or your DNS servers IP addresses. So how this subnet mask is doing means, when you have the IP address, that IP address will be masked with the subnet mask bits to identify the network portion of your device as well as the host portion of your device. So how it will be do? It will work on to identify the network address and the host portion of any of your devices on your network. It will take the IP address of your host, and that IP address is masked with the subnet mask. So then it identifies the network address part. How? By doing the logical ANDing or logical AND operation, that right from your left to right, it will, when you do the logical ANDing with the host address with subnet mask, you will get the network portion of the the device. So how it will be done? If you see these, the IP addresses, you can write in two different ways. Either you can write like the IP address as well as your subnet mask separately, or you can write them by using your backslashes, that the host IP address, that is slashed by the number of bits which are used per your network address purpose. That means here 192.168.10.10 by 24 means the first 24 bits are used for your network address purpose and the last byte is used for your host purpose. Right? So that is, by doing so, you can write the prefix length of your IP addresses in terms of your subnet mask. That, if you have the IP, the bit addresses like this, if you have the subnet mask this, so it says that it will use the 8 bits. First 8 bits are used for what? Your network address purpose. In a 32-bit network, the first byte is used for your network address and the remaining are used for your host address purpose. If it is by 16 means first 2 bytes are used for your network address and last 2 bytes for your host address. And if you find the IP address like this, that the subnet masking that 255.255.255. The 128, that means it is using the 25 bits for your IP addresses. So first 3 bytes plus first bit of your last byte. The remaining 7 bits are used for your host purpose. That means if you do the 2 to the power of 7, whatever the value comes, those many number of hosts can be there in that network. It is basically, why this subnet masking is used. That means if we have a network, private network, and we are having, suppose, only 6 devices. Okay? So instead of using all the 8 bits of your host portion to represent 6 devices, you can write, 2 to the power of 3 is equal to 8, right? So you can use only 3 bits, If you write 2 to the power of 3 is 8, but we are having only, suppose, 6 devices in our network, suppose, then, this 6 can be less than your 8. So last 3 bits you can use for your host purpose and remaining bits you can use for your, the network address purpose. So what is the advantage of this? The advantage is when the source try to connect with the destination, it can find the destination within a short time. Means instead of going and searching of your 255 devices in the network, it can simply search only 8 devices in the network. In that 8 devices, it can find the destination. So that will improve that will speed up the process of your packet transmission from source to the destination. So what the logical ANDing will be happen in this subnet masking means, by doing 1 and 1 means it is simply like your multiplication operation. 1 multiplied by 1 is 1, 1 multiplied 0 is 0, 0 multiplied 1 is 0, and 0 multiplied 0 is 0. So by doing this, to identify the network addresses of your IPv4 host, the logical ANDed by doing this bit by bit with the subnet mask, so that you can differentiate the network address as well as the host address. So how it will be done? If you have to determine the network address from your IP addresses of any device in the network, by doing this logical AND, what you will do, you will have the IPv4 host address. So that host address consists of network address plus your host portion, IPv4. And if you have the subnet mask, then by doing the ANDing operation of bit by bit, that means first bit of your network address and first bit of your subnet mask, that will be ANDing. So similarly, second bit ANDing with the second bit, third bit ANDing with the third bit, so bit by bit. So if you do this subnet masking, that will equals to this. From here, you are able to find the network address. In that network, this is the 10th host is there. Right? So you will have to determine the logical and network address. What you need, you must have the IP address of your host, and you must have the subnet mask. Because while configuring the IP address for any device, you will configure with the IP address as well as the subnet mask. Okay. And then from there, it is easy to identify this network address. Why this network address is required to identify? That means to do the network address translation. To do the network address translation. That means from your private network address to your public network address, and public network address to the private network address. Okay. So here, let me just, we have also discussed the network addresses, broadcast addresses, and your first usable host and the last usable host. Let me just play this video so that you can better understand these network addresses. See, the IP address are having the 32-bit logical address. So that is divided into 4 bytes, first octet, second octet, and your third octet. So that consists of your network portion and your host portion as discussed, right? So in the network portion, the length will vary. That depends upon the size of your network. If it is small network, then your network address bits are more. If it is large network, then your network address bits are less. So as the network is a range of your addresses, it is important to determine the address of your network portion. Because if it is a large network, suppose, so large private networks are there in this building. If you see, in the ground floor, first floor, second floor, up to fifth floor, so different networks are there. But they all are using the network address portion. In that network address, it identifies whether this belongs to this network building or not. So network address is the first address in the range. Then the broadcast address, that is the last address in the range, broadcast address, and the first usable host and the last usable host, who is the first device in the network and the last device in the network. So a device needs to know what network is belongs to in the order for forwarding the data correctly instead of forwarding in all the networks. It can selectively choose the destination network so that the network congestion can be reduced. So this is what you can find here, that to do this, the device compares their host IP and their subnet mask. So for any given host like 192.168.2.38, it is using 24 subnet masking bits. So from there it can compute the network address of any larger network by doing the AND operation. That is 1 multiplied by 1 and 1 is 1, 1 and 1 is 1, 0 and 1 is 0, 0 and 1 is 0. So it will give all zeros. So from there you can see the host portion is all zeros. Here. So we call this network address as your gateway address also. The network address as a gateway address. In that gateway, you will find if any number is given here, then in that network, that is the first device. If all the numbers are, suppose 1, that means that is the number of your broadcast address. If here is 0 and all are ones, means it gives 254 devices. That is the last usable device. Okay. So this this broadcast address is used to send the messages to all devices on the network, as we discussed. Unicast addresses means 1 to 1. Broadcast means 1 to many. So to do the broadcasting in that network, use the host portion as all ones. And if doing the multicasting, then in the host portion you will select only how many number of hosts that they can use. So suppose 5 or 6 of that network, you can mention in the host portion of that to determine. And to determine the first usable bits means the first address assigned to a first device in the network. And last one is, if it is 1, suppose this is used to the router, the gateway. Then from 2 to 254, those addresses, host portion addresses used for your devices, end devices. If all bits are zeros, means it is your broadcast address. Like this. So if you recall this, you can find the network address. First usable host is always a router. Last usable host is always an end device in that network, and you will have the broadcast address to communicate, send a message to every device in the network. So let me quickly go back to the one, how to do this subnetting and the broadcast domain in this. How to do that part, right? So in subnetting the broadcast domains means what? Your host portion should be all ones, right? Your host, for to do the broadcasting, the host portion should be all ones, so that it will broadcast to every device in the network. So if you see, if there is a large broadcast domain, suppose in this network, many devices are there, suppose. So in that, there is one LAN that connects, suppose 400 users that could each generate a broadcast traffic, so which can slow down the network and device operations, because many, all the links are occupied with transferring many packets in that. So it becomes, the network congestion. So that will reduce the network performance. It will become, slow down. So the solution is to reduce the size of your network of your 400 users into smaller in size. So instead of all the 400, in the same network, instead of that, you can divide the devices into, suppose, 4, private networks. So every private network may have, suppose, 100 devices. Or you can divide that entire 400 network end devices into 2 private networks. So what, if any device in one private network that is broadcasting, that will not affect on another network. So in that way, it will improve the performance of your network. So the solution is to reduce the size of your network to create a smaller broadcast domains in the process called the subnetting. So this subnetting is the smaller network space we call the subnets from that private net. So subnetting reduces the overall network traffic and it improves the network performance. So instead of having all the 400 users, it is divided into 2 different LAN 1 and LAN 2, by using, in every network it is having only the 200 users. But here you can see, if the all 400 users, they are divided into, suppose, 2 networks, their network address portion is same. The first. So here it is identifying, here it is 0 means the first 0 group network devices, and 1 means the second network devices. If it is 2 means, if instead of 2, if you are having 4, suppose, then you will have one more LAN here that will use the network address 172.168. 0.2, and having another network, it will use the network address that 172.16.0.3. So everywhere you will have the 100 users here, 100 users in this network, 100 users in this network, and 100 users in that. And further, if you divide, you can divide, to make another smaller one, you can divide that, you can use another subnet by using, suppose, 50 here and 50 here. You can make 50 here and 50 here. So subnetting is basically to reduce the size of your network. So why it is required means to improve the performance of your network. If it is a broadcast network, in that case you may use this subnetting part. So that subnetting, it is the job of the network administrators. They can group these devices like your first floor of this building, second floor, third floor, fourth floor. So it can group these devices, and for first floor, it may give the IP address that the private IP address that in ground floor, it may give the IP address that 10.10.1.0, and your next floor, first floor may be assigned to your 2, next floor assigned to your 3 and 4, like that. If number of floors in this building increase, suppose, so number of subnets will be configured, right? So once, if you take any organization, in that organization it can divide the organization by department wise. In that department, you can identify the individual device by their hosts. So what are the different types of IP addresses are there in this case? So if you see the type of your IP addresses, you can find the public IP addresses and private IP addresses, but the classes of your IP addresses as defined as class A, class B, and class C IP addresses. So class A IP addresses, they starts with the network address at 000, okay, and host address is also 0, that starts with your 8 bits. These are very large networks. So by 8 means what? It is using the first byte for your network address, and the next bytes are host address, your host address, and your host address in the IPv4 format. First byte is network address, remaining 3 bytes are your host address. Okay, and it is designed, these class A addresses are basically designed to support the extremely large networks with more than your 6 millions of that. So how you will get this? How many hosts it can accommodate means here 255, 255, and 255. If you write this 2 to the power of 255 to the power of 255 to the power of 255, these many number of hosts can be accommodated in this network, class A network. So that is almost your 6 millions of host addresses. And in class B host addresses, so as said, it starts with the 0 network address and ends with the 127. Why? Only first byte is used for your network address purpose. So if you write 2 to the power of 8, you will get the 127. So the network address starts with 0 and the last usable network address portion is 127. If you go to then the class B address starts from the next address, that is 2 bytes are used. That means first 2 bytes are used for your network address purpose of your IP addresses, and the next 2 bytes are used for your host address purpose. So how many, the number of hosts it can accommodate means 2 to the power of 255 to the power of 255. So it will accommodate the approximately 65,000 hosts, the addressing. And when it use the 2 portions, the first byte starts from your 128 and the ends with the next byte of your the 191. Okay. So and class C network address, it use the 3 bytes for your network address purpose and 1 byte for your host address. Okay. So those 3 bytes are used. So you can see this. The first byte starts with the 192 and the first byte ends with the 223. So this is designed to support the smaller networks with the maximum of 254 hosts in one. That is what we have seen the first usable address and last usable address in the network. So there is also a class D, which is used for your multicast the block that consists of the IP address 224.0.0.2 239. So these IP addresses used for multicasting purpose, right? So the entire classes of your IP address is classified as your class A is uses the 50% of IP addresses. Your class B use 25% of IP addresses. Class C use the 12.5% of your IP addresses, and class D and E, which are used for your multicasting purpose, they use the 12.5% of your IP addresses. So here in class A, the total networks it can accommodate 128 networks. 128 networks. So if you take the UTSA, suppose if UTSA is having suppose 50 networks, for example, UTSA is having 50 networks, then which class IP address is used? If UTSA is having only 50 networks, 50 private networks, suppose LAN, or 50 LANs are the local area networks, then which class IP address will be suitable? Is it class A, class B, or class C? So for that, you just remember this. Class C is used for what? Small networks. Class A is used for your extremely large networks, and class B is used for your moderated large network. So that means you can use the worldwide, or for internet purpose you use class A networks, and for your metropolitan area we call the MAN, metropolitan area networks you use the class B, and for the private area we call the LAN, you use the class C networks. Right? So there are some IP addresses which are reserved IP addresses, and these reserved IP addresses specifically used for only the assigned task. So what are the? There are the blocks of addresses called the private addresses and the public addresses. So the private addresses, it is very important for your the exam purpose also. There are three series of private addresses are there. One, it starts with 10. Okay. So if any address starts with 10 and use the only first 8 bytes for your network, it is the first series of your network private IP address, and it ends with 10.255.255. That means if any IP address starts with 10, it is a private IP address. It is used in the LAN. And if any address starts with 172 2 bytes, that means this is class A, class B, class C. If any from class A, this series is reserved for private IP addresses. From class B, that uses the 12 bits for network address. So that starts with the 172.16. If anything starts with 172.16, that is also private IP address. And class C is, it uses the 16 bits. In 16 bits, the first 2 bytes are suppose 192.168. It is also a private IP address. So if you have any IP address like 191.168.0.1, is it a private IP address or public IP address? If you have a IP address, a device is having an IP address 191.168.0.1. Private or public? Private. Public. It's a private, it's a public. Which one? Whether this address is a public IP address or private IP address? Yes. Because this is out of the range of these services. It's a public IP address, not private. If any IP address starts with, suppose, 178.16.0.0, is it public or private? If anything, it's a public. If anything starts with 11.0.0, public. If anything starts with 10.1.1.0, and if anything starts with 172.16.0.228, and 192.168. Suppose 0.254, these are all private. Why? Because they started with this series. They are reserved IP addresses as private IP addresses, right? So don't be confused in that one. If you ask that, tell what are the different private IP address means. If anything starts with 10 dot, remaining 3 bytes, it may be anything from 0 to 255. If any series starts with 192.168, remaining 2 bytes, it may be zeros or up to 255. Private. If anything starts with 172.16, that's also private. All other are public IP addresses. So public IP addresses are basically used for what? The internet purpose. So in this figure, if you see this network 1, it is using 10 dot, started with 10 dot, that means it is a private network. This is also private network, this is also private network. So all these private networks are connected with internet where it uses the public IP addresses. So when this private IP address reach to your the network edge, we call this gateway also. The last router, which is an interface between the network and your internet, is the gateway, or we call the network edge router. Okay. So this job of this network edge router is to translate the network address translation, translate this private IP address into public and public IP address into private. So from sender side, sender perspective, private IP address converted into public. From receiver side, public IP address converted into private IP address. So your IP header may consist of source IP address as your 10.0.0.0 and destination IP address is 192.1. So in that, by doing the subnet masking, it finds one is starts with 10, another is starting with 192.168. That means they are two different networks. They connected through internet. Okay. So as said, the default gateways, the job is, the default gateway is a host forwarding decision. Okay. So the another role of the network layer is to direct the packets between the hosts, source and destination. So a host can send a packet to itself or the local host or the remote host. So it can send to itself or send to the local host in the same network or send to the remote host which is outside. Remote host means in the internet. Right? So here the IPv4, the source device uses the own subnet mask along with its own IP address and the destination. So IPv4 address makes this the destination, means that determination. Okay. So in this case, the default gateway, what is the major role that it plays? The default gateway network device that can route traffic to other networks. Within the network means up to switch it will be that. So on the network, the default gateway is usually a router, as we said. So it has a local IP address in the same address range as the other host on the local network for incoming link, for incoming link, okay, of your router. It uses the local IP address. But when it is connected with the internet, this side, the other side, it can accept data into the local host and it must forward it out to the local network. But when it is routing the traffic to other network, the default gateway requires a send traffic outside the network. So traffic cannot be forwarded outside the network with this local IP address. So the default gateway address is not configured or default gateway is down. So what it will do? The local IP address is required to translate. So here it used the network address translation to convert the local IP address into your public IP addresses. Right? So here the host route the default gateway here in this scenario, if you see PC1, that having the direct connection with this switch. So in this local area network, they are using the IP address 192.168.10, and the last bit is used, last byte is used. Suppose 10 means your PC1, 15 means your PC2. So PC1 can send the data to PC2. So the packet goes through switch and router and comes back to switch and come is one way. If they are using the MAC address, suppose, then the switch can transfer that packet directly to this without reaching that. So this IPv4 host receives the IPv4 address of your default gateway either dynamically by using your DHCP protocol, and having a default gateway configured, it creates a default route into the routing table. So PC1 and PC2 are configured with IP addresses, and the default gateway is configured with the 1, the host byte, because it is also one device in the network, local network. Okay. So the host routing table, it consists of the Windows host, that the root print are the network static routing protocols commands can be used to display the host routing table in your command line. You can use the root print or your network static routing protocol. Netstat space your -r is used. This command is used to display the network, the routing table of your router. So in that routing table, it will have the source IP address, destination IP addresses, and the network translation addresses also. So that, by giving this command, netstat-r command, on your PC, if you open the command prompt of your PC and write this, then it will give the routing table, that the active routes, which consist of your network destination, network mask, default gateway, and what is the input interface, incoming interface and outgoing interface. Because every router is having the local area network IP address and the public, it goes to your internet side. So this table is having which interface it is coming, whether input interface or outgoing interface. So it gives all the IP addresses which are associated with this routing table. So comes to, we'll just try to discuss this IPv6 portion. So as IPv6 is designed to be a successor of your IPv4, so you can see this, the internet address provider, we call the ISP, internet service providers, are categorized into the different locations, geolocation. One is ERIN, another one is the RIPE, APNIC. So these are the, this is 1, 2, 3, 4, 5 are the major location. Only these authorities, organizations or agencies are having the rights to distribute the IP addresses. For IPv4, there were 7 agencies, but IPv6, there are, the 5 agencies are there. What are those agencies means? Sorry. Okay. So this IPv6 has a larger 128-bit address space, and it can provide up to 340 initial possible IP addresses. And the most top the internet service providers, such as your the YouTube, Facebook, or Netflix, have also made the transition from IPv4 to your IPv6. So what is the need of this means, as the network growth increased, the most of the IP addresses, IP version 4 addresses exhausted. So they cannot accommodate any more devices. That's why they are using the IPv6. So with increasing the internet population, the limited IPv4 address space that issues with the network address translation to your IoT, that the times has begin with the transition to your IPv6 in this case. So the format of IPv6, it use the hexadecimal format. So in the hexadecimal format, it use from 0 to your F bits. Okay. So IPv6 is having 128 bits in length. So written as a strong of the string of your hexadecimal values. So every 4 bits is represented by the single hexadecimal. So if you divide 128 by your the 4 bits, it will give you the 16-bit segment of your hexa octets. Okay. So this IPv4 address format that uses the hexadecimal format, and it will write in IPv4 we write that 192.168.0.0. We call this dotted decimal representation or binary representation also. If it is converted into all zeros and ones, there is a binary string, but if it is in the decimal format and separated with dot, in the same way hexadecimal or IPv6 addresses are represented with the colon, with each X consisting of your 4 hexadecimal values are separated with these colons. So each X is a single hexatext, and which is a 16-bit or your 4 hexadecimals. So that can be represented in this fashion. So there are certain rules are associated with this IPv6. Is rule 1 is omit the leading zeros. It omit the leading zeros. So in the hexadecimal format. So suppose the 4 example ways to omit this leading zeros as 0, 1, AB. Suppose 1 byte is there. This can be represented as your 1 AB. Leading zeros are omitted. So this can be written as like this, and this hectare can be written as this. So any leading zeros are there, they can be omitted. That is rule 1, representing. In rule 2, it use the double colon to separate. A double colon can replace any single or continuous string of your 1 or more 16-bit hexas. So that, for example, if you have the hexa that hexabytes given that the IPv6 format of this can also be represented as by doing the double colon of these leading 0 bits are there. They are separated with the double colon. Means if in between, inside the bytes, if you find the zeros, then that can be separated with the double colon. And the prefix length is the basic size of your IPv6 is 128 bits, so separated into your 64 bits, and 64 bits are used for your interface ID. So this 64 bits can be represented in the hexadecimal. This can be represented in this 0001. So here you can find the prefix length can identify the dotted, the decimal subnet mask, or the prefix length, that is the slashes notation. So if you have the IPv4 address, suppose 192.168.1.10 with the dotted decimal subnet, this is equivalent to this portion as we discussed, right? In the same way, IPv4 with 24 is called the prefix, whereas IPv6 is called the prefix your length. So that is similar to your IPv4 prefix length, and it is strongly recommended to use this 64-bit interface ID for the most networks in the larger network part, right? So this video, in the next class I'll try to play that video for you. So ultimately what we say is, in the TCP IP suite or the OSI model, there are the network layer use the IP addresses, data link layer use the MAC address, we call the physical address. So why these addresses are used means these addresses are basically used to identify the end device or network device in the network part, right? So that is what we use. In OSI model, it is defined the IEEE 802.2 and 802.3 standards to represent the addresses. One is your MAC address, another one is your IP address versions. The IPv4 means 32-bit hierarchical address. It is having the class A, class B, class C addresses, where IP6 is using the 128-bit hierarchical addresses. Why? Because the IPv4 addresses are exhausted because of the internet population, right? So, and to check it out, when we talk about the routing, the network protocol like IPv4 or IPv6, the basic service of network layer is to establish a connection between source and destination and maintain a path from source to destination. So to maintain the path information, it maintains the path table, or we call the routing table, route table. Okay. So to check it out whether what is there inside the route, you can use the command that netstack -r, or you can use the route print command to display the routing table of your network layer, right? So with this, I would like to stop this session, and if you have